Now, average velocity. So we want to talk about the difference between average velocity and instantaneous velocity. You would have done average velocity in up to year 10. Your average velocity of an object moving in a straight line is the time taken from t1 to t2, is the ratio of the change in displacement over the time taken. So if s of t is the displacement function, the average velocity is basically your, this is when you do like your distance over time.
Average speed.
That's your average speed. All right. So in middle school, up to year 10, you would have done average speed, and you would have done distance as something always positive over time. So average speed is always positive. Because you've done distance travelled over time. Okay? Whereas now we're talking displacement. So displacement is a what quantity? A v for vector. So velocity is also going to be a vector quantity.
I still don't know what velocity is. Why is it just speed?
It is talking about the change of distance, but now because we've been using this displacement function, so we've got a positive and a negative, it's telling us about our direction. So are we, if I'm walking to the right, I'm getting more positive, I'm going fast in this direction. All right? So how do I then talk about going that same speed in the negative direction?
Minus.
A negative velocity. No, I'm not talking deceleration yet.
Oh my God, how?
Let's leave that. We are just talking how fast am I going? And I want to be able to differentiate between I'm going fast this direction to the right or fast this direction to the left.
The minus sign means
Yeah, so the positive velocity means I'm getting more positive, I'm moving in the positive direction, and negative means I'm moving in the negative direction. Is that okay?
So it just means that the velocity is going like exponentially.
No. So and that's exactly it. We'll get that complication in a while. All right? And we can just do that as an average by going, what was my change in displacement? All right? How far I moved in the right? I've moved 4 meters to the right. Over how long did it take me? 2 seconds. I was going 2 meters per second. Or if my displacement was 4 meters to the left, so I've gone minus 4 meters in 2 seconds, my speed, my velocity is minus 2 meters per second.
Your speed is still 2 meters.
Because it's still 2 meters per second, average, but I've moved to the left. All right? So the point, there's 2 things I need you to understand. One is average velocity, where we're taking 2 separate times and 2 separate displacements.
What was the first time? 0.
Whatever. It could be 0, or it could be between time 2 and time 5, or whatever. So you can pick your time interval. This one is saying instantaneous. So I'm moving instantaneously now. How fast am I going? Or now, how fast am I going? All right? And the only way you can get an instantaneous velocity, so that's like our little sketches here, this is instantaneous. At this point, how fast is it going? At this point, how fast is it going? We're talking about the slope of the tangent. So we're back to differentiation. We're back to taking the limit of our displacement function for a tiny little interval of time as that interval gets smaller and smaller.
First principles.
That's first principles, exactly.
Oh my gosh.
All right? It is exactly first principles, it's your limit, but we've got a displacement function, and here our h is a small part of time.
What is H?
So h is a remember 80 before was a little amount of x, and we took that little bit of difference getting smaller and smaller. So it's a small amount of time. And we want, so it's basically doing that rise over run, but that's getting smaller and smaller. So we're talking that from first principles gives us our instantaneous velocity, or we're going to use differentiation.
So for the average velocity, should we write down distance over time, or should we write down st to
Well, depends whether if you're given it as a displacement function, you're going to be using that. If you know it's travel, you're not going to be just getting a basic distance traveled over time. That's like the luxury of Year 10. What you'll be getting now is going to be more complex. And most of the time you're going to be doing an instantaneous velocity rather than an average velocity. It does happen, but mostly it'll be the other one.
So average velocity is different to average speed.
Yes.
For instantaneous velocity, since isn't the first principles thing the same as that easy way we differentiate?
Yes.
So we wouldn't have to do that thing.
But sometimes it says use first principles.
It's occasionally you'll get having,
principles.
yeah. But in a question on kinematics, it'll be just differentiation. All right. Peter, was there a comment, question? All right. So velocity is a vector. It's got magnitude and direction. All right. If velocity is positive, it will be a function of time. If that's greater than 0, what's it meaning?
It's getting, but it's going to the right.
It's moving to the right.
So instantaneous velocity is just differentiation. The whole limit thing we don't do.
Yeah, the way that. If when our velocity function equals 0, what's happening? It is stationary. All right. Does that ring? It's at a stationary point.
Oh, darn it.
All right. Can you see the link? When f dash x is 0, it's a stationary point, or it could be a turning point. All right, so this is an application. So here I am moving. I have a velocity. I now stop and turn around. It is now a turning point on my graph. It is a stationary point because I've turned around. All right, so
And distance we go back down again.
so it's not moving. It's stationary. Everything we've done in chapter 16 is just being applied into something moving. When our velocity is less than 0, what's it doing?
Yeah.
Moving to the left or down, whichever direction you're looking at. Moving to the left. All right. Speed is a scalar. What's that going to mean?
There's no direction.
So the speed has no direction. It's always going to be greater than equal to 0. It's always positive or 0. Right? No direction. How fast are you going? That's a speed question. What is your velocity? Is a vector question. It wants a magnitude and a direction. All right? Doing well. Okay, can I move on?